topic is Kerberos version 4. As we know, Kerberos is a computer network authentication protocol which allows the nodes to communicate over a non-secure network and allows to prove their identity to one another. Version 4 of Kerberos makes use of DES to provide authentication. We will try to understand its working by making use of several hypothetical dialogues. Each successive dialogue adds additional complexity to counter the security vulnerabilities revealed in the preceding dialogue. The first dialogue is a simple authentication dialogue. Here we will have a client C, a server V, and an authentication server AS. This authentication server will have the identifier of each client and its corresponding passwords. So, whenever a client requires a service from a particular server V, it will request the authentication server by sending its identifier, the corresponding password, and the identifier of the server from which it requires the service. The authentication server will check in its database if the identifier and the password matches. Then it will respond to the client's request by sending a ticket. This ticket is in the encrypted form. It is encrypted with the key KB, which is known only to the authentication server and the actual server. So it cannot be decrypted by the client. It can be decrypted only by the actual server. And this ticket will have the identifier of the client, the address of the client, and the address of identifier of the actual server. Once the client receives the ticket, it will request the actual server by sending its identifier along with the ticket. Now, the server, once it receives this request, it will decrypt the ticket and verify if the identifier on the ticket and the identifier sent by the client is same. If it is same, the client is authenticated and is allowed to use the services provided by the server. The problem with this kind of simple authentication dialog is that the password which is shared is shared in the form of a plain text, which can be taken by the opponent and can be used for using the services. So we have a more secure authentication dialog where we also have a ticket granting server along with the authentication server. So whenever the client requires a service, first it will request the authentication server with its identifier and the identifier of the ticket granting server. Here we are not sharing the password. The authentication server will respond to the client's request by sending an encrypted message, which will be encrypted with the key KC, which is known to the client because this is related to the client's password. And also a ticket or to the ticket granting server. This ticket will have the key which is shared by the authentication server and the ticket granting server. So it can be decrypted only by the ticket granting server. It will have the identifier of the client, the address of the client, identifier of the ticket granting server, timestamp 1 and the lifetime 1. Timestamp is the time when the ticket was generated and the lifetime is the time granted by the server to use this particular ticket. Within this lifetime we have to use this ticket, otherwise it will expire. So once this is received by the client, it will decrypt and it will send to the ticket granting server the identifier of the actual server and the ticket granting server ticket. Once the ticket granting server receives this, it will send another ticket, which is ticket V, ticket to the server. When the client receives this ticket, it will send the particular ticket to the actual server. This ticket will have a key KB, which is shared by the ticket granting server and the actual server, and this can be only decrypted by the actual server. Once the server receives this ticket, it will decrypt it and it will check the identifier of the client, address of the client, identifier of the server, timestamp, when this ticket was generated, and the lifetime within which the ticket has to be utilized. The problem with this kind of more secure authentication dialog is that the lifetime associated with the ticket granting ticket, either it is too short, where we have to ask the password repeatedly, or if it is too long, which is a greater opportunity to replay, like reuse the ticket. Another threat is that an opponent can steal the ticket and use it before it expires. So we have another version where the first step is authentication server exchange to obtain the ticket granting ticket. So first what the client will do is client will send its identifier and the identifier of the ticket granting server along with its timestamp to the authentication server. The authentication server responds to the client by sending an encrypted message which will be which is encrypted with a key KC which is known to the client. The client will decrypt this particular message, and it will have all this information, that is the ticket shared by the ticket granting server and the client, identifier of the TGS server, timestamp, lifetime, and the ticket to the TGS. And this TGS ticket will have all this information, and this can be decrypted only by the ticket granting server. It will have the key. It will have the ticket granting server key and client key, which is shared, identifier, address of the client, identifier of the ticket granting server, timestamp, and the lifetime. Next, when the ticket granting server receives the ticket from the client, it will verify it will have the identifier, it will have the ticket granting server ticket, and an authenticator. This authenticator will have the key shared by the client and the ticket granting server, the identifier of the client, address of the client, and another timestamp, that is timestamp 3. Once the ticket granting server receives this request, it will respond to the client by sending an encrypted message uh, that is encrypted by the key KC, TGS, which is shared by the client and the ticket granting server, and the key which has to be shared by the client and the server, identifier of the server with the timestamp, and another ticket which has to be sent to the actual server. Next is the client server authentication exchange, which will be to obtain the service. The client will first send the ticket key and the authenticator to the server. The server will decrypt this ticket and verify if it is correct. And the authenticator will have all this information along with the timestamp. This is the version for authentication dialog in the form of diagram. So the first, what happens is the user log on to the workstation and request the service. This is the first session is the one per user logon session. Here the client will request a ticket to the ticket granting server by to the authentication server. The authentication server will verify the access right to the database, and it will respond by sending the ticket to the ticket granting server along with the session key. Next, once the client receives this, it will send the ticket granting server's ticket and request for the service. The ticket granting server will respond to this by sending a ticket along with the session key. This is once per type of service session. Next, once the client receives this, it will send the request to the uh, actual server, and all the verification is done, and the service is provided to the user. This is the Kerberos version 4. We have next is Kerberos Reels. Kerberos Realms is a full-time Kerberos environment which consists of a server and a number of clients and number of application servers, and it requires the following things. All the user IDs must have hashed password which will be stored in the database, and all the users registered with the Kerberos. The Kerberos server must share a secret key with each server. All servers must be registered with the Kerberos server. This is about my topic.